Good afternoon, Pranay. Today I am
Yeah,
going to
good
discuss.
afternoon, sir.
Today I am going to explain the preventive measures to be taken in the case of expansive soil. So, if it is found that it is expansive soil, the following remedial measures to be taken in the case of expansive soil. The first one is modification or stabilization. That means the swelling nature of soil mass can be modified by adding some external additives. That means it is also called as stabilization. So the inferior qualities of expansor can be nullified by adding some external chemicals, cement, fly ash like that. So second one is prevention of migration of moisture. So when the swelling soil, when it receives water, swelling will be takes place. When water is dried out, shrinkage will be takes place. So all these things are happen when it receives water. So that's why we need to seize the water or we need to prevent the water to enter into the expansive soil. So that is the second method, prevention of migration of moisture. So the third one is design of special type of foundations. So without going any ground improvement technique, without going any ground improvement technique, so directly we can design some special type of foundations like raft foundation, underground pile foundation, belted piers like that in the case of expansive soils. So this special foundation can counteract the swelling nature of the soil mass. So I'm taking the first one, modification or stabilization of expansive soil. So in modification or stabilization, we have the following techniques. The first one is pre-wetting, second one is compaction control, third one is chemical stabilization, fourth one is soil replacement, fifth one is CNS layer technique, pressure injection, and heating. In the case of prevention of migration of moisture, we have the following four methods. One is horizontal moisture barriers. Second one is vertical moisture barriers. Barrier means it prevents the migration of moisture into the expansive soil. Drains, surface drains, subsurface drains. The purpose of drain is to collect, intercept, and dispose the water out of the expansive soil. The third technique is design of special type of foundations. So they are under rimmed pile foundation, belted piers, granular anchor piles, and raft or mat foundations. So all these four foundations, they can counteract the swelling nature of the soil mass. So without going any ground improvement technique, directly we can adopt this type of foundations. So I am taking the first one, soil stabilization or modification. The first technique is pre-wetting. That means wetting of soil mass prior to construction. So in the case of pre-wetting, the moisture content in the soil before construction is known as field moisture content. So we need these two technical terms, field moisture content. So the moisture content soil before construction is known as field moisture content, FMC. So the moisture content after construction is known as equilibrium moisture content, EMC. So if FMC is greater than EMC, the swelling may decrease. So field moisture content is greater than equilibrium moisture content, the swelling may decrease. So in order to increase the initial moisture content in the soil is flooded with water. After construction, the earthen bounds around the soil. So the main technique here is if field moisture content is greater than equilibrium moisture content. That means the moisture content before construction is greater than moisture content after construction, then the swelling may be nullified. So in order to increase the initial moisture, that's why we need to increase the initial moisture content of the soil. So in order to increase the initial moisture content in the soil is flooded with water after construction earthen bunds around the soil. So the first site is selected, certain bunds are constructed around the site. Then these bounds are filled with water. So the merits of this methods are this method is economical. No sophisticated equipments are needed. At the same time, we don't need 1 minute. హలో ఇంటికి వెళ్ళాను మా వాన పెద్దగా పడలేదు ఇక్కడ ముగ్గులు వేసుకుంది అంతే కొంచెంసేపు ఇప్పుడే కొంచెంసేపు మన ఆగిపోయింది. సరే ఓకే. ఏం ఏం చెప్పలేదు మనం మాట్లాడతాను ఫోన్ చేసి. So the merits of this methods are this method is very economical. That means skilled supervision is not required. At the same time, costly equipments are also not required. It is a very simple method. Just earthen bunds are constructed around the site, then it is filled with water. So demerits of these methods are it takes a lot of time because of low permeability of soil. My expansion are treated as clays, expansive clays. Clays are treated as impermeable soils. The perimeter soil is very less. So if you pre-wet the soil mass, what will happen? Because of low permeability, this water cannot penetrate through the soil immediately. So it takes more time. That's why it takes a lot of time to stabilize the soil mass. So due to uneven permeability, the entire depth of soil mass cannot be wetted with water. So in this side, at some time the permeability will be more, and some side the permeability will be very less. In some side, in some places, the permeability may be moderate. So that's why uniform pre-wetting is not possible. That means uniform stabilization of expansive soil is not possible. That is the demerits of this technique. The soil replacement technique. The second thing is soil replacement technique. So the soil which is swelling in nature, swelling in nature is excavated, then it is disposed away from the site. Then in place of excavated soil, the soil which is non-swelling in nature, it is placed and compacted. So here the soil which is in swelling, high swelling in nature is replaced by soil with which is non-swelling in nature. So the soil replacement technique. The soil which is expansive in nature is replaced with the granular soil or cohesionless soil. So granular soil means it is a sandy soil or a gravel material. It is a cohesionless soil. That's why it is non-swelling in nature. They don't have any negative charge. They don't attack the water molecules of the water molecule present in the moisture. That's why the soil which is expansive in nature is replaced with granular soil or cohesionless soil. So it is simple and economical method when depth of soil to be replaced is less. If the depth of the expansive soil is very less, then we can go for this method. So this method also very simple and also economical because the soil which is problematic in nature is replaced with the soil which is not problematic in nature. So demerits is it becomes expensive if non-expansive soils are not available near the site. So it becomes expensive. Granular soils are cohesionless soils. That means non-expansive soils. Examples are granular soils or cohesionless soils. When these soils are not available near the site, then it becomes expensive. That means we need to transport the soil from the available site to construction site. That's why if the non-expansive soils are not available near the site, it becomes expensive. The second thing is if permeability of granular soil is more, it allows the water to enter through it. So here we are using non-expansive soil such as granular soil or cohesionless soil. So sometimes it may be gravel soils or sometimes it may be coarse grained soils. So what happened is even though the soil is replaced with the granular soil, when during rainy seasons the water may percolate through this granular soil, again it reaches the expansive soil. So the problem is left as it is. So that's why if the permeability of granular soil is more, so it allows the water to enter through it, and also it reaches the swelling nature of the swelling soil, and also it causes the swelling of the soil mass. The third one is compaction control. So first we need to know what do you mean by optimum moisture content, dry side of optimum, and wet side of optimum. So the moisture content at which at which we can obtain maximum density is known as optimum moisture content. The moisture content at which the soil attains maximum density is known as optimum moisture content. Then the moisture content less than optimum moisture content is known as dry state of optimum. The moisture content more than optimum moisture content is known as wet state of optimum moisture content. So at optimum moisture content, the density is maximum. And right state optimum, shear strength is increases. And wet state optimum, swelling decreases. So in the case of a dry state optimum, the water content is less. Shear strength is inversely proportional to water content because S is equal to C plus sigma dash minus U into tan pi. So sigma dash minus U, that means total stress minus pore water pressure. So here pore water pressure is a negative. Shear strength inversely proportional to pore water pressure. So less the water, less will be more will be the shear strength. So in dry optimum, the water content or moisture content is less. That's why shear strength increases. And wet state optimum, the field moisture content is more, hence the swelling decreases. And wet state optimum already the soil is already swelling has taken place because of presence of more moisture content. That's why swelling decreases. So the moisture content which the soil obtain maximum density is known as optimum moisture content. So generally optimum moisture content is recommended to attain maximum density and improve the engineering properties of the soil mass such as permeability, shear strength, stability of slopes, bearing capacity, etc. So at raised optimum, pore water pressure is less, hence shear strength will be maximum. Hence, in order to increase the shear strength of the soil mass, the outer shell of the earth dome is compacted on dry side of optimum. So, on dry side of optimum, pore water pressure is less, hence the shear strength will be maximum. So, we need to maintain the stability of the soil mass in the case of embankment or earthen dams. Hence, in order to increase the shear strength of the soil mass or stability of the slopes, the outer shell of the earthen dam is compacted on dry side of optimum. Right side of optimum. So in on wet side of optimum, the moisture content is more and density is less when compared to optimum moisture content. So at optimum moisture content, maximum density will takes place, and also the maximum density takes place. And wet side optimum, moisture content is more than the optimum moisture content, and also density is less. So the density is less, the density is less, the soil is loose, swelling natural soil mass may be decreases. At the same time, moisture content is more, and swelling natural soil mass also here decreases. So the swelling natural soil mass depends on initial moisture and density of the soil mass. Hence, in order to reduce the swelling natural soil mass, expansive soil is recommended to compact and wet side of optimum. So in the case of expansive soil, in order to reduce the swelling nature of the soil mass, expansive soil is recommended to compact and bed set of optimum. The next one is chemical stabilization. In this method, the expansive soil mixed with some external material known as admixtures such as lime, cement, fly ash, sodium chloride, calcium chloride, sodium silicate, etc. So sometimes the chemicals may be added in combination to increase the effectiveness of the technique. So lime alone is used, it is known as lime stabilization. Cement alone is used in cement stabilization, and fly ash alone is used. It is known as fly ash stabilization. That's why sometimes in order to increase the effectiveness of the soil stabilization, we can use in combination of these chemicals: lime fly ash stabilization, cement fly ash stabilization, calcium chloride fly ash stabilization, like that. So when chemicals are added to expand the soil, the following reactions takes place. That the following reaction takes place. They are hydration, cementation, pozzonic action, consolidation, cation exchange, flocculation, and agglomeration. Coming to lime stabilization is very effective in the case of expansive soil. So it is simple and economical method when compared to other methods. It modifies the properties of the expansive soil. So when lime is added to expansive soil, the following reaction takes place: hydration, consolidation, cementation, pozzonic reaction, cation exchange, flocculation, and agglomeration. So lime stabilization is very effective in the case of expansive soil. So when compared to all other chemicals, because it is a simple and economical method when compared to other methods, it modifies the soil property. That means the nature of a swelling soil mass is swelling and shrinkage. It modifies the nature. That means swelling and shrinkage. Expansive nature can modify to non-expansive nature. So when lime is added to expansive soil, the following chemical reactions takes place. They are hydration, consolidation, cementation or progenic reaction, cation exchange, flocculation, and agglomeration. When lime is added to expansive soil with water, a chemical reaction takes place between lime and water, resulting in liberation of heat of soil. So when lime is added to the when water is added to lime, what will happen? A chemical reaction takes place between the lime and water, resulting in liberation in heat of the soil mass. So due to liberation of heat, the water content in the soil reduced. Due to evaporation of water, the water content in the soil mass will be reduced. Hence, plasticity and the plasticity index of the soil also reduced. Consequently, expansion in soil may be reduced. So that is the mechanism here. So with hydrogen means when the lime is added to expansive soil, a chemical reaction takes place between water and lime. So this because of this chemical reaction between lime and water, it results in a liberation of great heat in the soil. So due to liberation of heat, the water content in soil is reduced, hence the plasticity and the plasticity index of the soil is reduced. Consequently, the expansive nature of soil is also reduced. Next, consolidation. When water is added to the lime, the volume of lime increases. So really, when water is added to the lime, the volume increases twice. So the increase in volume applies a pressure on the surrounding soil particles. As the lime increases its volume, it applies the pressure on surrounding soil particles, which resembles the increase in consolidation pressure. So when lime is added to the soil mass, lime occupies in the wide spaces of the soil mass. This lime tends to increase in volume. This lime tends to increase in volume. That's why as the volume increases, it applies the pressure on the surrounding soil. That's why the soil may be consolidated. The cementation or pozzonic reaction. So the chemical reaction between the soil and lime and water makes the soil hard and consequently the swelling nature of the soil may be reduced. So when lime is added to the expansive soil, it can make a chemical reaction between the it can make a chemical reaction between the soil and the lime and water. So because of this chemical reaction, the swelling in nature of the soil mass may be reduced. So lime binds the soil particles. Lime binds the soil particles. So because of binding of the soil particles, cohesion of the soil increases. When cohesion increases, its association also increases. Next, the cation exchange. This is very important in the case of lime stabilization. So expansive soil exhibits the swelling nature due to presence of sodium monochloride clay mineral. So this sodium monochloride clay mineral is highly expansive in nature. So lime consists of large amount of calcium, 2 double plus. So lime consists of a large amount of calcium. When lime is added to the soil, the lower valence sodium ions present in soil is replaced by higher valence ions present in the lime. So when lime is added to the expansive soil, the sodium monotonate is replaced with calcium present in the lime. When lime is added to the soil, the lower valence sodium ions present in soil mass is replaced with higher valence ions present in the lime due to cation exchange of soil. The calcium monotonate is non-expansive in nature. So because of this cation exchange, sodium monotonate is converted to calcium monotonate. So sodium monotonate is highly expansive in nature. Calcium monotonate is monotonate climate is very less expansive in nature. That's why the swelling nature of the soil mass is reduced due to cation exchange process in the expansive soil. So, cation exchange process. So flocculation, agglomeration. So when lime is added to the soil, heat is liberated. So due to liberation of heat, water content in the soil may be reduced. The reduction in water content, increase the attractive forces between the soil particles. Hence, all soil particles attracted towards So all the soil particles. So the reduction in water can increase the attractive forces between the soil particles. Hence, all the soil particles attract towards each other. Such phenomenon is known as flocculation. So during flocculation, so the contaminants consists of a negative charge on the surface. When it is absorbed by chemicals, it when lime is added to the when lime is added to the soil, heat is liberated. Due to liberation of heat, water content in the soil may be reduced. So the reduction in water content increases the attractive forces between the soil particles. So hence all the soil particles attract towards each other. Such a phenomenon is known as flocculation. So flocculation means because of the attraction between the positive and negative charge, the soil particles moves close to each other. So such a process is known as flocculation. So the flocculation of the particles, due to flocculation of the particles, the particles attach to each other and grow in size. The size of the particles and specific gravity, which is termed as agglomeration. So as the size of the particles increases, the specific gravity of the soil mass also increases. So the process in which the soil grows in size is known as agglomeration. The increase in size, decrease in surface area of soil particles. Consequently, the soil becomes inactive or insensitive. So, due to flocculation and agglomeration, the size of the particle increases. As the size of the particle increases, the surface of the soil particles decreases. Hence, the plasticity index, plastic limit and plasticity index drastically decreases due to increase in the size of the particles. Hence, the soil can be pulverized because of reduction in the plasticity index. The soil can be pulverized easily due to decrease in swelling nature of the soil mass. Next, pressure injection method or grouting. So pressure injection method or grouting. So grouting means a borehole is made, then the borehole is filled with chemical slurry or cement slurry or lime slurry, any other grout material with or without pressure, with minimum pressure, with maximum pressure. So grout material is introduced into the borehole with pressure or without pressure. So pressure injection method of grouting. When the depth of expansile is more, pressure injection method is lime stabilization is suitable only for shallow depth because the effect of lime stabilization is limited to only shallow depth. When the depth of expansive soil is more, pressure injection method is suitable to stabilize the expansive soil. So the depth of the soil is more, so this particular pressure injection method can be suitable for suitable to stabilize the expansive soil. So in this method, boreholes are driven up to a depth of 4 to 5 meters or up to a depth of active zone. So in this method, boreholes are driven up to a depth of 4 to 5 meters or up to a depth of active zone. Active zone means the depth up to which expansion and shrinkage of soil will be taken place is known as active zone. So then the chemical is mixed with water. It is injected into the soil under pressure. So after making borehole in the expansive soil, a chemical mixed with water. It may be lime plus water, or any chemical plus water, or any other chemicals plus water is injected into the soil under pressure. So the slurry flows through the wires into the soil mass and interacts with the soil mass. So the interaction taking place between soil and these growth materials. So the interaction is the swelling nature of the soil mass. So in this method, the slurry is injected into the soil under pressure or lime slurry. So lime slurry means lime plus water. Cement slurry, it is also called as cement plus water. Lime fly ash slurry, that means lime plus fly ash. So both are mixed along with water. Chemical slurry means chemical plus water. So pressure injection method is a deep method. Lime stabilized method is a shallow method. It's the heating of soil mass. This is called as a thermal method. Thermal methods. So in thermal methods, we have two types of methods. One is heating of soil. Second one is freezing of soil mass. So in the case of heating of soil mass, the soil is subjected to heat at a temperature of 500 degrees centigrade. The suitable number of bores are drilled in the site. The boreholes are filled with the coal, then it is wetted with petrol or diesel, then it is ignited. So suitable number of boreholes are drilled in the site. So the boreholes are limited to the boreholes are filled with coal that is wetted with the petrol or diesel, then it is ignited. When the coal is ignited, automatically it burns the soil. So sometimes heater coils are used instead of coal. So instead of coal, sometimes in some areas coal is not available. So in such a case, the heater coils are used instead of coals. So the method is very costly and hence rarely used to storage the expansive soil. So heating a soil method is very costly. So sometimes heater coils are used instead of coal. The method is very costly, hence rarely used to stabilize the expansive soil. So purchase of coals and also heater coils are very costly. So heater coils are consumption more power. That's why this method is not recommended in the case of expansive soil because of highly expensive in nature. The coil is so here heating of soil by using heater coils. So borehole is made in the boreholes up to required depth the borehole is made and then at the bottom of the boreholes heater coils are placed. So through these heater coils the surrounding soil is um, heated so that the swelling nature will be reduced. Next thing is CNS layer technique. CNS layer technique means cohesive, non-swelling nature. So it is also one type of a soil replacement technique. But in the case of soil replacement technique, the soil which is expansive in nature is replaced with the soil which is non-expansive in nature. So in earlier soil replacement method, we used to fill the to replace the material with the sand, granular soils. So when granular soils are used because of high permeability, the water flows through the granular soil. Again, it reaches the expansive soil, and because of this interaction, the swelling nature of soil mass increases. So here CNS layer technique means instead of granular soils, we can use cohesive non-swelling soils. So it is a cohesive. The soil is cohesive. That means it is a clay soil. So why? Because clay soil? Because of less permeability. So when the permeability is less, even though during rainfall, the water cannot percolate through the soil. It cannot reach the swelling soil. That's why it should be swelling. It should be cohesive soil. It should have a low permeability, non-swelling nature. At the same time, it is non-swelling nature. So it should not swell. It should have cohesion and also it should not swell. So it is called as cohesion non-swelling soils. The CNS layer technique. CNS means cohesive. The soil is cohesive but non-swelling in nature. The Cutty in 1917 developed the concept of using CNS layer technique to reduce the effect of swelling. So the soil which is expansive in nature is replaced by a clay soil having cohesion but no clay minerals of expansive variety. So the CNS layer has a low permeability. It cannot allow the water to enter through it. But the soil is replaced with the sandy soil. What will happen? Because of high permeability, the water can percolate through the sand and it reaches the bottom of the reaches the expansive soil. So the approximate properties of these CNS layer techniques are swelling pressure. For CNS layer technique, the swelling pressure is in between 100 to 150 kN per meter square. Our thickness is 0.75 into 0.85. So the swelling pressure of soil is in between 100 to 150. We need to go for thickness of a seamless layer is 0.75 to 0.85. The swelling pressure is in between 200 to 300. Then the thickness of the CNS layer is 0.9 to 1. The swelling pressure is 350 to 500. The thickness is in between 1.05 to 1.15 meters. So the properties of CNS layer are, so clay, that means the size less than 0.002 microns, 15 to 25%. The range is 15 to 25%. Silt, 30 to 45%. Sand, 30 to 40%. Gravel, greater than 2 mm is 10%. So consistency limits, the soil should have 30 to 50% liquid limit, 20 to 25% of plastic limit, 20 to 25% of 20 to 25% of plastic limit, 10 to 20% of plasticity index, and the shrinkage limit is greater than 15%. The swelling pressure of a CNS layer technique, CNS layer is very less. It should be around 5 to 10 kilonewton per meter square. So the clay mineral that contains in the CNS layer is kaolin or illite. The clay minerals present in the CNS layer techniques, kaolin or illite. Because in the case of kaolin, the two structural units are bonded by hydrogen bond. So hydrogen bond is strong in nature. It cannot allow the water to enter to the lattice structure of the clay mineral. In the case of illite, the two structures are bonded by potassium ions. That's why the clay mineral is not exhibits medium swelling and medium shrinkage. The shear strength of CNS layer technique at optimal second MDD is maximum entry is 100 shear strength 15 to 35 kN per meter square. Consolidated drain shear test is C equal to 10 to 30 kN per meter square. Phi equal to 15 degrees. With this, I am so another points are there. Prevention of migration of moisture. So when expansion of soil takes place, when it receives the water. So when the entry of water into expansion is prevented, then there is no issue of this expansion and shrinkage of soil mass. So that's why we need to maintain some barriers. They are horizontal moisture barriers, vertical moisture barriers, surface drains, and subsurface drains. Horizontal moisture barriers. So the name itself it is a horizontal. It is a barrier to water. It is placed in horizontal direction. So an impervious apron constructed over the surface of an expansive soil is known as horizontal moisture barriers. An impervious apron constructed over the surface of an expansive soil is known as horizontal moisture barriers. So a barrier is created horizontally over the surface of the expansive soil. So it prevents the entry of water into the expansive soil. It prevents the entry of water into the expansive soil. Vertical moisture barriers. So an impervious membrane constructed around the site vertically extending up to a depth of active zone in order to prevent the migration of moisture beneath the foundation is known as vertical moisture barriers. So an impervious membrane, it is an impervious membrane constructed around the site vertically extending up to a depth of active zone. Active zone means the depth up to which the soil is active. That means the soil can be affected by water is known as active zone. So in this case, an impervious membrane constructed around the site vertically extending up to a depth of active zone in order to prevent the migration of moisture beneath the foundation. It is known as vertical moisture barriers. So surface drains. So collection, interception and removal of surface water is known as surface drains. The collection, interception and removal of surface water only is known as surface drains. So a gravel layer is placed around the site at the top of the expansive side so that these gravel layers collect, intercept and remove the surface water, hence it is known as surface drains. So subsurface drains. A pervious soil layer is constructed around the site, extending up to a depth of active zone in order to collect, intercept, and dispose of subsurface water. It is known as subsurface drains. So a pervious layer is constructed around the site, extending up to a depth of active zone in order to collect, intercept, and dispose of subsurface water. It is known as subsurface drains. So in next class, I am going to discuss about the special type of foundations which are adopted in the case of expansive soil. Any doubts, Pranay? If you have any queries, you can ask Pranay.
No, sir. No, sir. 25, sir.
Okay.